So this is an introduction to partitioning, and I will see how much time we have. We'll show you lots of demos with this, how you can work with this. If you would like to replay the demos and work with the big databases, here are the links for the slides and for the demos and for the databases. I take the big database here because partitioning makes fun when you have big data or lots of data. So I use the ERP demo database, and I take the orders table with around 60 million rows, and that's quite interesting to see how it can perform. Something about me, not the commercial, just only take care of the email address. So when you have any questions concerning the topic or anything SQL Engine related, just drop me an email. I would be happy to answer you. You can do it whenever you want, by day and night. So this is our short agenda. They're very short here. I talked to you about what is partitioning and when you should use partitioning. And then we go immediately into the demonstration. So I show you the concept, the components on the concept, about partitioning, file groups, some best practice, what you should consider when you're dealing with partitioning. And then I show you the examples where you can speed up your DML and your DDL commands when you're using partitioning. So what is partitioning? Well, partitioning is quite easy to understand. I think the so-called poor man's partitioning is that you distribute your data from one big table into lots of small tables. So that means for every single year you have one table, and then over all of it you create a view, and you access all the tables by this view. And that's exactly the same how partitioning is working. So partitioning is it's building horizontal groups of rows which are mapped into individual partitions in the same DB and in the same table. So my demo data, what I'm working with, is quite easy. I have a table called dbo.orders. We have 9 columns in it, 60 million rows, and around 7.5 gigs of data. The data where I receive the data from does not have any indexes. And you see here that I will partition it by year. So we have this is 60 million rows. I have around 2.5 million rows per each year, which I want to use in my partitioning demos. So the partitioning without partitioning, I call it, was before 2016, for the poor man's partitioning, something like this. We were creating lots of simple tables, single tables, for every year, one single table. So that was a typical thing. For developers, it was a pure nightmare. So I saw developments where they first checked, hey, what is the date? And then they decided to go to the dedicated table. Doesn't make really sense, to be honest. So what you can do easily is you create a view over it, and then you access the view which contains all the select statements to the underlying tables. This was the core concept before people were coming to use partitioning, because partitioning is from the core concept exactly the same. The only thing what we do not have a view, but we have a table, and the table itself is then separated into different partitions. But that is a completely transparent process for you. So the user does not see whether it's partitioned or not. You can see it in the execution plan later on. So the benefits when you're dealing with partitioning is that you can data quickly transfer or access very quickly, efficiently, while you're maintaining integrity of data collection, for example. Maintenance operations. This is something where everybody of you who knows to deal with big data, a big problem. Anybody of you is a DBA and have problems with index maintenance, index rebuilds, all this kind of stuff with really, really big tables? Yeah. So I have one customer who has one single table, which is around 1 terabyte of data. When they do the index rebuild, it takes hours. But what will you do if you have a 24/7 database running? And the only thing what you can do is run it in an enterprise edition with online index rebuild, but that's a nightmare. With partitioning, you can completely resolve this because you only take the actual data, do the index rebuild on them, but not on the cold data. And that goes very quickly. This is something where partitioning can definitely help. Unfortunately, lots of people are thinking when it comes to partitioning Few people might think, well, partitioning, that is something where I can speed up my queries. No, not really. Partitioning is not the main concept for speeding up your queries. The core concept is to speed up your data loads or data manipulation. The query performance may be improved, but therefore there are some requirements which you have to fulfill. So what are the components when you're dealing with partitioning? Well, it's very easy. We have only 3 points. The first thing is that we can have different file groups. I strongly recommend to do that, especially when it comes to backup restore operations. You need to have a partition function and the partition schema. The file group decision is an architectural decision, and that is something what you really have to take care of. When I see partitioning, very often it is done by putting everything in the primary file group. That does not help if you have to fulfill SLAs where the hot data should be, after a crash of the database, be present immediately. Because if everything is in the primary file group, you have to restore the full database. And now think about a 10 terabyte database, and you have everything in one file group. And then you restore, and you restore, and you restore, and it takes time. With partitioning, you have the possibility to restore the hot data immediately, and afterwards, when the business is up and running, you restore the rest of the data. That is a cool feature or a cool topic of partitioning. One cool thing is that you can scale your workloads, that you can scale your database. You see in this here that I have just only one file group, but what you can do is to speed up the data loads is that you have multiple files. You all know the technique of TempDB, right? Why do you have multiple files in it? Because we want to get rid of the possible contention. And that is something what you can have with the multiple files in a file group in the same way. When it comes to partitioning with a customer, and it has a big database, then I always recommend to put every single partition on a separate file group. And that is what I will do here in all my demos. Whether you have only a few number of rows in one partition, or you have billions of rows, it doesn't matter. The good thing is when you separate it to different file groups, that you now can perfectly scale your workloads. For example, I have one customer in automotive who has a production circle around. There are around 100 points where they grab information where the slide is, actually. And they are writing all at the same time. What we did was we were creating a table, the table where it stores the data, with 100 partitions. For every single point, one dedicated partition. And they immediately get rid of the contention they had in the databases. So this is something where partitioning can speed up your DML operations. It's a fantastic feature for that. So, and if you, for example, if you work in a company, or if you have a database in a company where you have, for example, 16 machines producing, let's say, some products, but one of them has a more heavy workload than the others, just put more files to that file group and you can scale the DML operations. So in this example here, the machine on the file group number 3 is producing so much data that we cannot, that it slows down when we just only have one file where we write the data to. So we just added a few more files to scale the workload. But just only for this partition, while the other ones with smaller machines can scale perfectly with just only one. So partitioning in combination with file group gives you a perfect tool to scale every single workload. I could strongly recommend to do it that way.
Java, so that's not publicly available right now. But if you wanted to follow through with that, or you wanted to use that, you can at some point in the future. The .NET one is already available.
The file stream. The question is, can you do that with file stream?
And if you're a Java programmer,
unfortunately, I actually have to skip this question. I don't know, but I will take care of it afterwards and come back to you.
What is Cosmos DB?
So there are a few components you have to. It's quite hot, you see. I think that now it looks like Sonic the same way here. So you need to have a few components, just only two. The first one is the so-called partition function.
I mean that it's
the partition function defines the number of partitions you want to use for the table, and how are the boundaries defined. I come later on to what a boundary is. So the partition function is mandatory thing what you have to create first.
Databases, you have things like
Let me show you how this works.
Integrity and,
so I first of all create the additional file groups. I have a database here. I hope that you can see it here. Here's my demo database. A very, very simple database, no tables in it.
And so at this point, I'm just going to point out, and
this is the default when you create your database. When you run it with create, come on. Yes, it takes a little bit. Okay, one database file on the primary file group and the log file. How boring.
From the trade-offs therein.
Okay, so what I will do now, I prepare my database for the partitioning, and what I do here is I have a repo store procedure which creates the table for me, and I give the limit to what date. So I now actually fill around 20 million rows into the database. It creates a table, and I have created 20 million rows in it. So the table I have here is now on only one partition. So that means on the primary file group, there is nothing what could benefit so far. Now we come to the point how the data are distributed.
Well, you know, obviously,
and you can see here that we have in total 306,000 data pages allocated, and it's all on one partition, the default.
I would say relational, either that or they're hierarchical or some combination of both.
Yeah.
And it's just that we have different techniques that you need to use to implement relationships. And these are non-intuitive, so you may not want to rely on your intuitions if you're coming from the relational background and you've never looked at a NoSQL database before.
A few minutes? Yeah, no worries. Yeah. Then I do some Sonic running here. So we have to stop a little bit because we have some problems, some technical problems. In the meantime, I try to run because that is from plastic. And when you see it's getting wet, you know that I'm really hardworking, okay? That looks cool, right? Tell me when the problem is fixed, please. I'm a smoker. You know that, but one moment. I do it this way. That looks more funny. That's cool, huh? I need to tell you a story in the meantime. I was in London, I would say 10, 15 years ago, and there was a musical, Mamma Mia. I think you all, coming here from London, you know this. And that was the most amazing musical I've ever seen in my lifetime because they had a technical issue the same way as we have here. Can you hear me? And while everybody was sitting there, in Germany, they all would sit there, say, we are waiting. And they would sit there for an hour if they must. But in London, suddenly, 3 elder ladies, they started singing all the songs from ABBA. And in a few seconds, the whole audience were singing these songs. So maybe you can now sing the Sonic theme. I don't know it. So, is the problem fixed? Is it okay now? Does it work? Okay, take another round. Oh, oh, that's good. Oh. Can I have more 5 minutes then for my session? Can I have more 5 minutes for my session then? Good. Okay, so everything is on one partition, and now what I want to do is now, for every single year, I create one file group with one file attached. I do it in a loop, that's quite easy. Here is the code. Go for it. And you see here are the statements, yeah? I say, create a new file group and put one file to that file group. Quite easy. So now my database has a completely new design. And you can see this here. One moment. That was open. And here we are. That is the first thing, the first preparation. So now I have for every single order year, one dedicated file planned. In the next step, we can then create the function. But before we do this, let's do a quick cross-check. And you can see here now, I have my primary file group, and for every single year, one dedicated file group. In the next step, I have to create the function. And the function is a very simple thing. So first of all, make sure that everything is dropped. And here comes one of the most important points when you're thinking about the function, because that is something what you really have to plan. The function could have a left-sided boundary or a right-sided boundary. And let me explain to you what this means. When a partition has a left range, it does mean that you have to enter, or the limit of this partition is the highest possible value. Everything will go from your side to the left side. Yeah? So we say that the boundary is the end of the year. If you have it right bounded, yeah, that's correct, right? Yeah, right. Then it does mean that your partition starts with the minimum value, so the 1st of January of a year. And that is something what you always have to take into consideration. Here is it as a chart. So you see here that the partition number 1, this is a left side function, and that means that the border for this partition is the end of the year, and so on and so on. You always have to have one empty partition. Where the empty partition is depends on the boundary of the function. You can very easily understand this when you see this here. For example, if I would insert an order back in the 1980s, no worries, it can be stored in partition number 1 because the limit is the end of 1992. But what happens if you insert data for the year 2019 or 2022? The partition 9 cannot store the data, so therefore we must have at least one empty partition which can store the data which does not fit to the boundaries. So if you have a left side boundary, the empty partition is on the right side. If you have a right side partition function, the empty partition is on the left side. Yeah, that is, I think, quite easy to understand. So what will I do? I created here with a left range partition. And you see here that I have the boundaries at the end of the year. Done. That's it. So now it's finished. But the partition function itself does not give you immediately the structure for the table. No, that is way too less. We have to do one thing more. The partition function determines where the data should go to. But the problem is here that we did not tell the SQL Server, hey, what table does use or should use the function and the underlying infrastructure. Therefore, we need this partition scheme. And the partition scheme is, let's say, it's the glue between the function and the physical abstraction layer. Okay? So the schema makes a connection between the function and the file groups. And let's show how this works. It's just so easy. Really, it's absolutely easy. The only thing what I do is I define a partition schema here, call it PF or as partition for the function order date, PF function, and then I tell SQL Server where should the function store the data in the different file groups. It's 1992 up to 2000, and the empty one, think about this, left side boundaries, the last one is empty. I easily say, take it to primary, no worries. So I run this query, and that's it. Now we have a complete partitioning infrastructure, and that looks like this. So here you can see that the file group 1992 will store values which are lower or equal to the end of 1992, and so on and so on. Now we have the infrastructure, and the big question now is, how can we now store the data in this partition structure? Well, even this is quite simple. Let's do this. I do this first with a heap. What I do, therefore, is that you can see how the workload immediately can scale is, first of all, I create an X-event session. This X-event session records every single access to a dedicated physical file when we insert data in it. Implement this, and now see this. I go into the management, extended events session, and here is my multiple file load, and what I can see here is the histogram. I will see the live data. So what you will see when I start the import process is the following. The value contains the file ID where I write data to. And the count is the number of writes we have per each file. And I always see this as a really fantastic thing when it writes to the data. So now I recreate my table, the orders table, up to the end of 2000, and I say, please use the partition underneath. And here we go. It's inserting. It takes a little bit longer, but look to this. To be honest, is that cool? We are writing simultaneously into different files. We can distribute our workload. We can spread it over multiple files. If you insert, let's say, single-threaded, it does not make a difference. But think about having a workload where thousands of clients will parallel write into your database. That will speed up your writing performance. Yeah? So now it's finished. And now let's see how the data gets distributed. Here we are. Go for this. And now we see that now, for every single partition, we have now around 2 million rows here in our system. When you now have a problem with the database, you need to restore it, and you have Enterprise Edition, you can restore every single file group online. So that does mean, let's say your manager is calling and say, oh, we need the data from yesterday. You say, no worries, I go for a coffee and then I restore it. Because the only thing what you have to do is restore first the primary and the last file group, and then you have the data. And afterwards, you can restore the other file groups. That is really a cool thing. And if you want to do this with a clustered index, so you say, I want to have a clustered index on the table, because everybody's recommending, hey, you need to have a clustered index. I don't think so, but okay, let's follow these requirements. And the only thing what you have to do is you say, let's create a clustered index on the partition schema. And when I run this, so it takes a little bit, but now SQL Server creates the same table as a clustered index. Very, very simple and very easy. Wow, it was really quick. 7 seconds. So now we want to distribute data over partition. The querying comes later on. But exactly this is a challenge. So maybe you know, come on, here we are. So what problem? This is what I told you. We can skip this. This is okay. This is only what is not allowed. You always know that Microsoft SQL Server will always, in every feature, something have which is, this is not allowed. And here we have a few of the data types we cannot use with partitioning. So then let's load some data into it. And here comes the big, big benefit of it. Yeah, where it is, number 40. Distribute data over partitions. Come on, here. So here is what I do now is I create my table, and stop, this is something wrong. That was wrong, the wrong one. Sorry. Yeah, we want to come to querying, because that is definitely a challenge. Querying a partition table, hi. Most people think, well, we have partitioning, everything is fast. I promise you this is not. This cannot be if you do not consider the partition key. So let's do it here. What I do now is I recreate the table. Here we are with 20 million rows. And then I create this clustered index on it. And we were expecting that everything is running fine. Go for it. Here we are. And now let's go. Whenever you're dealing with performance and you want to check it for you as a developer, use always statistics, I/O, and time to measure the data. Come on, it's running. No worries. In the meantime, I can do some cleanup here. Okay, so here is the first query. Go for this. What would you say when you run this query? Say, give me everything, every order from the year 1999. I run this with an execution plan. It goes quite quick. We get 2 million rows back. But let's have a look to the execution plan. So what you see here is that SQL Server is using an index seek. That was expected. Why? Well, okay, we run the query on the index key. What SQL Server here is doing is, you can see here that SQL Server, come on. Okay, then this way. You can see here that SQL Server is telling you, well, it is partitioned. And the second thing, that is a little bit weird, is that SQL Server is telling you, well, I had to access 2 partitions. What? Why 2? We only are running queries for 1999. The reason is that we will touch the boundary of the next partition by defining it as smaller than the value of the next partition. That is the reason why SQL Server is accessing 2 partitions. And what you can see in the properties is how SQL Server will use the partitions. Let me see this here. Excuse me. Come on. Here we are. Sometimes it's working, sometimes not. It's really weird. Where is partition? I can see the partition numbers. Oh, gosh. It's partition. What the heck? So normally what you will see here, this is something really, it's happening that you can see, I have accessed n number of partitions, and then the second parameter tells you what partitions it has accessed. Maybe it's working with the next example, hopefully. This is live, this is demo, yeah? So now when I run this query, but taking this query like is smaller or equal to, now I do not touch the next partition, and that means that when I run it, it's the same result, by the way, but now SQL Server will only touch 1 partition. You see that at the actual partition count. So really take care of how you define the predicates to not access other partition than the one you really want to have. So now this one, and now you will see the disaster. Look to this. I say, give me all the orders from the customer with the ID number 10. So I would say, well, it's a clustered index. I know it's on the order date, but let's see what SQL Server is doing. Unfortunately, SQL Server is doing a full scan. We do not have an index on it, okay? You see, full scan over all 20 million rows. And what SQL Server had to do is, we had to go over all partitions, look to the actual partition count. So SQL Server was accessing all the partitions. Let me increase it a little bit that you can see it easier. Look to the actual partition count, so all partitions were touched. And this is something what we want to try to improve. And now comes the big mistake. See this. What I'm doing here is I create a non-clustered index on the customer key. This is something, if you're developers, you would say, yeah, that's okay. That's what I would do too. Let's do this. So now I get an index on the customer key. And now we look to how the index is designed. And there is something what is quite interesting. Do you see that there is something weird, let's say weird, going on? I did not mention to create the index on the partition schema. I only said put it on the customer key. SQL Server saw that, hey, the table is partitioned, then I create an aligned index which is following exactly the same partitioning rules as the table itself. And that brings some problems. Let's go for this one. Because the index will definitely not improve the performance. I go for this. I would expect, hey, yeah, that will help. Look for this. Whoops, what? Yeah. Look to this. Look how many partitions we have accessed. All. So SQL Server was walking through every single partition and was looking for the customer ID number 10. And that, in the output, demonstrated that SQL Server, or that the query, was accessing every single partition. This is not helpful, especially when we're thinking of heavy workloads where we block a partition. That means that this query will stop the same way until the lock is released. So that's something what we do not want to have. How can we solve this? Well, if you want to have a so-called not aligned index, you have to define this by defining on what file group or on what partition it should be created. In this case here, I put it on the primary. So now this index is not even more partitioned. Yeah, you see, this is just only one. And now it works perfectly by looking to this. And now we have a perfect index seek here. But due to the fact that we do not have any more partitions, we do not have to take care about, scanning 10 partitions. So this is something what you always have to take into consideration, because there are lots of problems with this, and I have one demo for this. I drop the index. Let's go for this. Come on. And now I want to create this unique index on the order key. And what will happen? The question is, I want to have the order key. This is an ongoing number. Yeah? It's 1, 2, 3, 4, and so on. It is unique. If I try to execute this, I get an error. The reason is very simple. Think about the partitions as internally as separate tables. So when we say we want to have a unique index on this order key, it does mean we want to have this unique on every single partition. We cannot tell SQL Server, hey, this is unique overall. If you want to do this, you have to have the partition key a part of the uniqueness of the index. Otherwise, you cannot implement this. When I run this is working. But keep in mind that this index is now distributed over, or the table is distributed over the order date. And now let's see whether this is working. Come on, give it a little bit of time. My computer is in the jet lag. It's 1 hour behind its normal working time. Nah. Normally it would take only, yeah, now it's done. Okay, so I run this query. Here it is. And when I look to, look to this. What's the problem? We go over all partitions again because it's looking for the unique ID per customer key and order date. So the ID itself is not unique. Only in combination with the order date. That means that the query will always be performant if you have the partition key included in your query. This is a must-have. So do not think that when you're doing partitioning that always your queries will run faster. Now we have it. It's just only going over one partition. But there is another problem, a typical problem, and my thanks goes to Itzik Ben-Gan. I know you all know Itzik. Let me show you one big problem I had with a customer, and he and Paul White, he helped me out. Let's go for this query here. I have an aggregation. This is a typical workload, normally with a date with my customer. They wanted to have the max date from the last order for some aggregations. And here is my query. Give me the last order key that I can add a new one with this +1. I run this query. It was quick, but look to this. That's crazy. Keep in mind, we have an index on it. We have a clustered index on the order key. But its SQL Server is running a scan over it. And the problem with the scan, that it does not only say, okay, take from this partition, from this. No, no, no. It takes all. That's funny. So what is the reason? Well, the problem is here that the max has to be the combination of the clustered indexes, the key and the date. So there is no ordering that we can immediately go to the max and then we find it, because it could be in every single partition combined with the date. So what can we do? What I'm doing now is I create this index on the order key. The expectation now is, well, now I have a single index on the order key, on the partition schema, and then it will help. That was my idea, by the way, too. Okay, yeah, that is true. One moment. Go. Here we are. So I create this index on the order key. That's something what typically you would do. And then we see here that it is now perfectly distributed. You see here my different partition numbers, and here comes the point. Here is my first query. Give me the maximum, or the max order key only for 9092. Let's see what the execution plan is. And that is a scan. Yeah, the problem again is here that we're looking in one partition, but the problem is SQL Server cannot determine it. So what can we do? The problem is here, this seek predicate. It is a range scan from to, and that makes it impossible for SQL Server to seek immediately. And here's the trick. What you can do is, and you'll see that it will be immediately very fast. Let's say you know that every single year is on a dedicated partition. The first partition is the year 9092. You know? So when I now say, give me the max of the order key, which is in the first partition, I do not name it as a range from start date to start date, but say, go into this partition and look for the max number. Okay. Look this. Go. It looks like a scan. Don't worry. It is by the top limited. Yeah, it's the top one. So we get one row. The reason why you see the 900, by the way, is because I have a 2019 Enterprise Edition. The query is running with batch mode. Yeah. So SQL Server is looking for one row, returns one. That's the typical thing when you run a max on a value on a column. And now we are using this with a trick. And this is from Itzik Ben-Gan. When we know that we need to go into every single partition to grab the max value, then we can do it like this. First of all, let me show you the CTE here, the common table expression. This is the result. I get every single partition ID. Then I take this CTE here and put it in a cross apply to hand over the partition number from P, from this CTE. And now look to this. I run this, execute, and this is my plan. It looks more because we have more complexity, but SQL Server is quicker than before. We do not have to scan SQL Server. Look to the IOs. That is, in single ways, it's peanuts. So you see here that indexing can help, but you have to be aware that how you define your indexes and how the indexes perform. Unfortunately, no, are we finished now? No, we have 10 more minutes? It's finished? No, 10 more minutes, great. Or you raise your hand or you say, stop, okay? Yeah, I can't see it because of it's blinding me. Okay, one more demo and that is good. So DML, DDL operations, I like this. This is definitely the way I like to implement indexing. And I want to show you how this will work. Data loading without blocking. So I go and create my table. I create a clustered index on it. Come on. So here we are. I have it on the order date. And now I want to start the statistics. You know what happens, just a question to the audience, what will happen if you insert more than, let's say, 5,000 rows at one time into a table? You know about lock escalation? That means when you insert more than 5,000 rows, SQL Server has so many locks on that table that it converts it to a table lock. So that means that no select statements could run against this table because the table is locked while the transaction is running. And this is a problem when you're dealing with big data and you're pushing the data into your table. So here is the point what I'm doing. What I want to do now is we have year up to 2000 in our table, and now the year 2001 should come into the play. So what I'm doing now is I create a new file group 2001 and add a new file to this. So now, excuse me, now I have the infrastructure for the new data for 2001. The only thing what I have to do, this is a DDL command, is I expand the schema and say, hey, the next one you use is not the primary, but this is the orders 2001 file group. And the last step is that my partition function needs to know that from now on, the data for 2001 should go into this new partition. And this is a so-called split function or splitting in the function. Done this. Finished. Here is the infrastructure that you can see this. Bang. And you see here is my orders, now 2001, the partition number 10, and there are 0 records in. New. So far, so good, so easy. And now we come to the point. Here is my transaction. I put it in a transaction that you can see the logs. And see what I'm doing. I say, insert into my table everything from 2001. So now approximately 2 million rows gets inserted into the table, and now we run into a big problem. Let's say this will take, let's say, 1 hour. In the meantime, when this is running, nobody can, 15 minutes, thank you. Nobody, absolutely nobody can access the table. Why? Okay, you can use no-lock, but to be honest, who is using no-lock? Huh? I see it so often, goodness. So look to this. Here is my locks. That has come from the first. Let's see for the object. Object, where is my object? Come on. So, and here we are. Bang. And now you have a not scaling system. That means if anybody else wants to access the table, it does not work because we hold an exclusive lock on the table. And this exclusive lock prevents any shared locks on this table. No select is running, can run. So what can we do? And for God's sake, there is a solution. Partitioning. Yeah, let's roll back the transaction. And here comes the next point, what you always should take into mind. To be honest, I'm really wondering about that SQL Server does not do it automatically when you create partitioning. No, you have to name it. You see here that you have to change the lock escalation mechanism for the table. By default, when you create a table, the lock escalation mode is set to a table. So that means that whenever you have more than 5,000 locks on with one transaction, it escalates immediately to the table and locks the whole table. If you are dealing with partitioning and you want to scale it, always, really always, don't forget to alter your table and say you want to have a lock escalation with auto setting. And this auto setting gives you a great, great, great opportunity. It gives you now the chance that not the table gets blocked, but only the partition. Yay! That is so cool because now when we are dealing with this, we are entering data for 2001, all the other select statements on the former one will work on every other partition. Yeah, so it's inserted, and look to this. Go. So here is the X lock. This is, and I need to enlarge it. This here is my partition, heap or B tree structure, and it's exclusive locked. And look to this, my object is not. My object has a so-called intent exclusive lock, which means, well, I need to lock something, but that is in the hierarchy a little bit more down. So whenever we run now selects on different partitions, no worries, it can work. So now you have a pretty cool scaling system. You can do your workloads into the database, into your data warehouse, for example, while on the other hand, the analytic reports can run on the former data. A really great thing. But as I said, you have to make sure that it is always always set to lock escalation auto. This is one thing. That means that you insert data by insert into select star. But think about one big problem if you have a high availability system. You have an always on availability group. Who's working with availability groups? Think lots of you, right? And now let's say you have a very hard delay to your DR site. So what is your main concern? That the transaction log will grow and grow and grow, and it takes time to transfer it to the secondary. The problem here is when I insert this, this creates a huge amount of transaction logs. Because for every single row, it's single log, that insert row, insert row, insert row. There are 2 million entries in the transaction log. How can we do better? We can do it better by switching from DML, data manipulation language, to DDL, data definition language syntax, by pushing data into your table. And I want to show you this as a last demo, and I hope that you will be really impressed by this. And this is a typical scenario what you will see in data warehouse loadings. So the split range is your friend here. So now, actually, my system has data up to 2001. Now we want to insert the data from 2002. I, again, create a new file group for 2002, and then I make sure that the table does not exist, and now comes the point what I'm doing. I first of all create or put my data, which can come from different subsystems, into a staging area, a staging table. Everybody of you who is familiar with architecture of data warehouses know about the staging concept. That means that we load the data into a different table, and then we work with the table, and then we push it into the data warehouse. That's exactly what I do here. So the first step is I create or I push my data from 2002 into a new table, completely different from my partition table. And then what I have to do is, and this is a really important thing, otherwise it will not work, I have to put this table into exactly the same partition schema as my target table. Otherwise, we cannot put them in. So now I do this, go for this. What? Sorry, yeah, this is, yeah, with drop existing. Yeah, sometimes, this is when you play around with this, you know? So I create a clustered index. What? Create clustered index on, maybe. Gosh, well, what's happened? What's going on here? Oh, this is so stupid. Look what I did. Oh, my master is so funny now. It's a production system from a bank, so no worries, I can delete it afterwards. I need to do it again, one moment. So, oh my goodness. Yeah. So now, drop table, insert it. See the others clapping hand, that mean, oh, it's done now. Come on. So it's query, create a clustered index. Now it works. When you do it right, it will work. And then, again, the same procedure. The only thing what I then do is I expand my schema to the next year, alter my partition function to say, please consider the orders from 2002. Yay, that's okay. And you see here a split range. Now, come on. Give it some time. Why? Oh, that's okay. So, and now what I have to do is very simple. The only thing what I have to do is I need to know what is the partition for 2002. And with this knowing, I only say switch my staging table into this table. And look what we have locked here. Done, finished. Less than a second. We have 2 million rows inserted into a table because it's a DDL command. The only thing what happens here is we took the formerly created staging table and now it becomes part of my partition table. We do not have to transfer it again. And this is the minimal transaction what we have here. It takes only a minimum of less than a second, and then my data are in. And that's it. I drop the table if it exists, and now I have the data in the table. So, ladies and gentlemen, I really hope that you enjoyed what you have seen here from partitioning, and I want you to ask for the feedback. It's quite important for us. I'm so happy to be here, that I was here with you together. Enjoy the rest of the party and have fun. We see us here on the floor. Thank you very much, and bye-bye.